Welcome to Incomplete Intelligence, where we dive deep into the ideas shaping the future of intelligence. I'm your host, Min, an AI leader with over 15 years of experience. I've spent my career building AI systems that work in the real world, especially in high-stakes fields like healthcare. Along the way, I've seen just how far AI has come, and just how far it still has to go. In this episode, we're asking one of the most fundamental and debated questions in artificial intelligence today. Does AI really understand? Or is it just memorizing? Let's start with the journey that brought us here. From the very beginning, AI has been a story of chasing generalization. In the earliest days, that meant symbolic systems, expert systems built on human-defined rules. These systems used logic and symbols to represent knowledge. If you gave them the right rules, they could perform useful tasks, like medical diagnosis or planning, but there was a problem. The real world is messy. The more rules you added, the harder it became to manage. When something new came along, something outside the rules, the system broke. Symbolic AI was brittle, powerful in narrow domains, but unable to adapt. Next came statistical machine learning. Instead of writing rules, engineers started feeding models labeled data. Algorithms like random forests and support vector machines could find patterns and make predictions. These models were flexible, but only in narrow ways. They couldn't adapt to new tasks without retraining, and they couldn't learn new things on their own. Then, deep learning changed everything. Neural networks, especially when trained on massive datasets, learned to create their own internal representations. They didn't just match patterns, they learned features, abstractions, even structure. These models scaled from millions to billions of parameters, unlocking surprising abilities along the way. And as we scaled them up further, something unexpected started to happen. AI models began to solve problems they weren't explicitly trained for. Language models could write code, solve math problems, translate obscure languages, and even explain jokes, without task-specific training. This ability to generalize to new tasks, sometimes called emergent behavior, felt like something more than memorization. It felt like the beginning of understanding. But is it? That's where the debate begins. A recent study on memorization of large language models and logical reasoning tested how well models could handle logic puzzles. When the puzzles were nearly identical to training examples, models performed almost perfectly. But when the puzzles were altered, just slightly, accuracy dropped sharply. The takeaway? The model hadn't really learned logic. It had learned to recognize the training patterns. An MIT study echoed that concern. It found that many standard benchmarks for reasoning were too simple, and that models often passed them by, picking up on superficial patterns, not deep understanding. When challenged with harder adversarial questions, model performance often collapsed. Another paper, So-K Memorization in General-Purpose Large Language Models, went even deeper. It broke down different types of memorization, exact recall, fact repetition, style imitation, and even algorithmic replication. The core insight was sobering. Models are excellent at echoing the past, but still limited in true abstraction. So where does that leave us? I tend to believe that today's AI, for all its advances, is still a continuation of the same path we've been on for decades. From models with hundreds of parameters, to millions, to hundreds of billions, we've followed the same trajectory. Make it bigger, feed it more data, hope it gets smarter. And in many ways it has. With enough scale, today's AI can mix and match solutions across domains. Faced with a new task, it might not understand in a human sense, but it can assemble a solution by recombining fragments of what it's seen before. It's like a puzzle solver that doesn't know the final image, but has seen enough pieces to guess what fits. That's powerful, but it's also fundamentally limited. Because all of this, every impressive output, comes from knowledge we've already fed into the system. At some point, the model has seen all it can see. And memorization, no matter how clever, reaches its ceiling. That's why many researchers now believe that the next leap won't come from scaling alone. It'll come from rethinking what it means to learn. Future AI systems may need to reason, not just recall, to discover, not just repeat, to understand uncertainty, context, and nuance, to learn actively, reflectively, even autonomously. Because if true understanding is more than memory, then the future of intelligence must be more than prediction. Thanks for joining me for episode 2 of Incomplete Intelligence. If this sparks some thought, follow the show and share it with someone who's curious about where AI is going, and what it means to truly know something.